Hello, good night, sir. We are from Group 8 from the Statistic and Probability class. And for now, we are going to present about Section 8.4, which is testing the difference between proposition. And inside this group, there is me, myself, Andi Gamal Farabi Harist, Dimas Akmal Rajendra, Gede Samuel, Ray Aidin Faqih, and Frederick. So, the first one. The two-sample z-test for proposition. It is used to the difference between two population proportion P1 and P2. There are three conditions are required to conduct the test. The first one is the sample must be randomly selected. The second one, the sample must be independent. And the third one, the sample must be large enough to use a normal sampling distribution.
Okay, so for the formulas itself, one of them is the mean. The mean of the sampling distribution for the difference in sample proportion is simply the difference between the population proportion, which is P1 minus P2. Furthermore, to the weighted estimate, the formula is x1 plus x2 and 1 plus n2. The x1 is the success of the first sample, the x2 is success of the second sample, and we're combining the both sample to a single estimate to the overall proportion under the assumption that the population proportion might be equal. Furthermore, for the standard error, that we use the pooled proportion and its complement, which is 1 minus p, to estimate the overall proportion. The standard error decrease as our sample sizes increase, which makes sense because larger samples generally gives us more precise estimates. Okay, next. Okay, so for the test statistic, the test statistic is we have our observed difference between sample portions, which is simply P1 minus P2. This is the raw difference when we're looking between two groups. And for standardized test statistic is that we observe difference is statistically significant and we need to standardize it. In this formula, the z statistic tells us how many standard errors our observed difference in sample proportion is away from the hypothesized difference.
Okay, so next we're going to discuss still about two sample z-test to test difference between proportions. So first, we have to verify that the samples are random and independent. Second, you have to find the weighted estimate of P1 and P2. And third, you have to state the claim, identify the null and alternative hypotheses. You have to state H0 and HA as well. For fourth, you have to specify the level of significance and identify alpha. For five, the next step, you have to determine the critical values, also identify alpha. Next, you have to determine the rejection regions. And then you have to find the standardized test statistics and sketch the sampling distribution. Next, you have to make a decision to reject or fail to reject the null hypothesis. And finally, you interpret the decision in the context of the original claim. Next.
Okay, so here we have an example of a case study. So in this example, it says that in a study of 150 randomly selected occupants in passenger cars and 200 randomly selected occupants in pickup trucks, 86% of occupants in passenger cars and 74% of occupants in pickup trucks wear seatbelts. So at an alpha of 0.1, can you reject that the claim that the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks? Now we can go to the next slide, in which there is the solution to this case study. Next. Okay, yeah. So as you can see, 1 equals passenger cars and 2 equals pickup trucks. And from the data that we can see on the left side, we can figure out the x1 and x2 values, x1 being n1 times p1 and x2 being n2 times p2, with the total of x1 being 129 and 148, and x2 being 148. And then with those values, we can substitute it to the equations beforehand and get our p and q values, p being 0.7914 and q being 0.2086. Now, once we have our p and q values, we can also get our, we also have to check if n1 times p, n2 times p, n1 times q, and n2 times q is equal to or more than 5. And as you can see at the bottom of the note, they are all above 5. Afterwards, we can find our z value by substituting all of the necessary variables into the equation, and then we get a z value of 2.73. Next. And so we can conclude that the test statistic equals is 0. I mean, z equals 2.73. And the decision is, of course, to reject H0, because at the 10% level of significance, there is enough evidence to reject the claim that the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks. Next.
Example 2. A medical research team conducted a study to test the effect of a cholesterol-reducing medication. At the end of the study, the researchers found that of the 4,700 randomly selected subjects who took the medication, 301 died of heart disease. Of the 4,300 randomly selected subjects who took the placebo, 357 died of heart disease. At a significance level of 0.01, can you conclude that the death rate due to heart disease is lower for those who took the medication than for those who took the placebo? So, of course, the null hypothesis is that P1 is greater than P2, and the alternative hypothesis is P1 is less than P2. We're assuming that the death rate of those who took the medicine is less than those who took the placebo. So that's the and significant level is 0.01. We have the sample size. The first sample size is 4,700, and the second sample size is 4,300. And according to this graph, we have the rejection region on the left because it's less than, because the alternative hypothesis is less than. So we find the values of P1 and P2 by dividing X and N to get P1 equals 0.064 and P2 equals 0.083. Then we input a weighted estimate of the two. And by inputting the previous variables, we get 0.0731. You find the Q by subtracting one by P, and you input it all in. You attempt to find the Z value, the standardized test statistic, by using this large formula. And by inputting all the variables in, you find that Z equals negative 3.46, and that means that we should reject the null hypothesis. At the 1% level of significance, there is enough evidence to conclude that the death rate due to the heart disease is lower for those who took the medication than for those who took the placebo.
Okay, that is all the presentation from our group. Thank you for your time and see you. Once again, thank you. Thank you, sir. We love